All right, so rotations are turning a figure around a center point. So when you turn some figures around, there's some specific angles that are used, and you need to remember or recall what they look like so you have an idea of what you're doing. That would be a 90-degree rotation, and we do end up identifying clockwise, counterclockwise. So that would be counterclockwise. And this direction would be clockwise. And not only do we do 90 degrees, sometimes we also do 180 degrees, either to the left, clockwise or counterclockwise. And 270 degrees. Let's look at an example or what a rotation looks like. Say we have a center point and I just want to rotate this line, just that little line. I want to rotate it 90 degrees around this center point. What is it going to look like? Well, you got to either do it with patty paper or get a visual, or you can use angles. And since I said 90 degrees, I'm going to do 90 degrees counterclockwise. So I want to swing this up 90 degrees. Now the easiest way to do this is to pick an endpoint and draw a line. And I'm going to draw another line 90 degrees from there, which means it's going to land right here. That endpoint, after it rotates 90 degrees, will land here. So where does this endpoint end up? Again, I'm going to rotate this one 90 degrees, and it'll end up here. And I'll do this one with the thinner marker. The line to that point, and a line to my new point, that creates a 90-degree angle also. So therefore, my new segment goes from here and here. So that is a 90-degree rotation. Notice the red segments connecting the points created a 90-degree angle, and my thinner lines connecting the other endpoints are also creating a 90-degree angle. Every single point, when it gets transferred, will create a 90-degree angle when you use the center as center of rotation as the vertex of the angles. All right, so let's do one more real quick so you can see how that works. This time I'll just do them very lightly so it's not so dark. So say I want to rotate, I don't know, this triangle 90 degrees. So I'm going to take one of my vertices, say the farthest one, and I'm going to draw a line to it. I'm going to create a 90-degree angle from there, equidistant from the center. So this point became this point. Where does this point end up? 90 degrees, I'm going to estimate here. That's about 90 degrees. That's where it would end up. Of course, to be exact, you would use a protractor. I have a graph paper, so it's I know not to go in between. I know it's going to be on a intersection point there. So my triangle is going to be, these two will be this two. So then I know that I got one more. This vertice will create 90 degrees with the new vertice somewhere over here, which means this is the point that I want. So this would be another 90-degree rotation counterclockwise. And it's a lot easier with the patty paper. Again, you're not going to always have patty paper, but you can, I don't know, carry around a compass, or a protractor, so you can measure the angles. Or we'll eventually develop some kind of rules that'll make this a little easier. Or we have developed rules. So example 1. Right, so given this triangle with these vertices, we're going to rotate (180°) about the origin. About the origin. So when it says about the origin, meaning you're going to rotate about the origin, meaning rotating around the origin. So we're going to have our axes, -4, 2 is A, B is -3, 4, and C is -1, 4. So here's my triangle. And I want to rotate this 180° about the origin. Now, there's a rule that when you're rotating, the signs will change. So if you have a -4, 2, my new A prime is going to be 4, -2. It's opposite, complete opposite of exactly what you had. So 4, 2 would be here. 1, 2, 3, 4, 1, 2, -2. This would be my new A. And then you take B. And the new B is going to be opposite of the entire point. 3, -4. And my new C is going to be opposite of those coordinates. So it would be +1, and since that's +4, it's now a -4. C. So that's a rule. When you're doing 180° rotations, about the origin, the formula is going to be -x, -y. So you have the opposite of whatever x was and the opposite of whatever y was. All right, so this only works for 180° rotations. Now, it doesn't matter if I go clockwise or counterclockwise because it's going to end up in the same place, right? I could have gone this way or I could have gone this way and you still end up in the same place. So let me just verify that it is going to be a 180° rotation, which would end up just being 2 90° rotations. So what you do is when you do have this patty paper, you're going to put your pencil at the center and you do one rotation. That's going to be 90°. And I do another 90° because our axes are already 90°. You see that it lines up perfectly. So that is for 180° rotations. Now there is another pattern that happens when you do 90° rotations about the origin. Say you have one, 2, B is 4, 2, and C is 1, negative 3. So again, we're going to rotate 90 degrees, we'll say clockwise, about the origin. That means that our center of rotation is going to be the origin. So quickly, 1, 2 is A. 1, 2, 3, 4, 2, that's B. And 1, negative 3, that's C. Oops. All right, so we have this triangle. It's a little thick, but we're going to rotate it 90 degrees clockwise about the origin. So I can take my patty paper. We'll do it this way this time first, and then we'll get the coordinates after. I'm just going to do the coordinates since that's the most important part. And you're going to go clockwise. So I'm just going to rotate it once. Land right there. So I'm going to have a point at, oops, I didn't label them, sorry. I don't want to lose track of which one was A, B, C. When you rotate 90 degrees, just one of the quadrants shift. So now A is 2, negative 1. And B is now 2, 4, negative 4. And C is now negative 3, negative 1. All right. So the rule was that your digits will switch, and then you got to pay attention to the quadrant that it's going to land in. So when you do a 90-degree rotation, your X and your Y digits will switch places. Now I say switch digits because it's not opposites. It's the digit. It's the distance from 0 is going to be the digit that is going to stay the same. I'm sorry, it's going to switch. So notice I had the digits 1 and 2. Now I have 2, 1. I had 4, 2. Now I have 2, 4. I had 1, 3. Now I have 3, 1. Now you're probably thinking, okay, so what's with the negatives? Well, there's another rule that we have to remember is where is it going to land and what the quadrants tell us. So remember, when you're in this quadrant, your X and your Y are both positive. When you're in this quadrant, your X is negative, your Y is positive. When you're in this quadrant, your X is negative, your Y is also negative. And when you're in this quadrant, your X is positive and your Y is negative. So that's what we need to use. So then you're just going to say, okay, well, A, 90-degree rotation lands me in this quadrant. What's in this quadrant? A positive and a negative. And then B is going to land me in this quadrant after 90-degree rotation. So that means I'm going to be also positive with a negative. And then this point C is actually already in quadrant 4. When you rotate it, it's going to land in quadrant 3. So that means you're going to have both negatives. So then you just double check that the signs are the same. And that's how you rotate about 90 degrees counterclockwise. So any 90-degree rotation, you do this trick. If you don't want any tricks, you just want to do it the real way, you can always just take this point, draw a line, 90-degree angle to the resulting point. So let's see, 2, oops, these are all primes. So 2, negative 1. Let's do this in red so we don't confuse the original image. That's my A. 2, 4, negative 4. That's my B. And negative 3, negative 1. That's my C. And that is my 90-degree rotation. And I can also show it with a patty paper. That's my original image. And when I rotate it, it lands perfectly on the bottom. All right, so there you go. Rotating figures about the origin, 180 degrees, 90 degrees, and the only one we did not do is the 270 degrees. So I can get this point into this quadrant by doing a 90-degree clockwise rotation. But I can also get this point into this quadrant by going 270 degrees counterclockwise. So doing a 90-degree clockwise is the same as a 270 counterclockwise. Just like a 90-degree counterclockwise would be the same as going 270 clockwise. So if you're given these instructions or given these instructions, they mean the same thing. You can interpret them either way. So you can literally take your patty paper and rotate it this way, or do a bigger turn and land in the same place. So there you go, rotating points about the origin.